I'm Randy Reed, editor of the Edison Report, and we are here at Chicago, and I am joined by Dave Djoy, the CEO of OLED Works. Dave, welcome.
Randy, thanks very much.
Well, thank you for sitting down with us. And I don't know a lot about OLEDs, but I spent some time at your booth in Frankfurt and was very impressed by what I saw. Tell our audience a little bit about kind of the evolution of OLEDs, where we are, and the trajectory.
Okay, well, in my opinion, OLEDs are a super cool technology and different than LED in many ways, but the same in the fact that they're both solid-state lighting technologies. OLEDs are layers of organic materials, very thin layers of organic materials between an anode and a cathode. You put a current through it, and it produces light over the entire surface. Generally, we use glass, but our facilities are agnostic when it comes to the substrate. So we can use plastic or glass or metal or other substrates. Right now, all of our commercialized products are made on glass, either rigid or thin glass. Thin glass conforms and can bend, and our first product we just released on thin glass. But our products traditionally have been made on rigid glass using hydrocarbon-based materials between an anode and a cathode.
Okay.
Very sustainable technology, mostly glass and hydrocarbon-based materials.
So tell us a little about the trajectory.
The trajectory, so OLED started back in the Kodak days. It was discovered at Eastman Kodak Company back in the 80s, and that technology really is a light source. Kodak advanced that technology mostly in display, and then focused on lighting after that. And really, people have been messing around with OLED since the early 2000s, making 20, 30 lumen per watt light engines with that technology. We've graduated our technology to 85 lumens per watt and high brightness. So another characteristic of our technology at OLED Works is we can produce quite a bit of light at about 83 candela per meter squared with long lifetime.
Okay, so in 5 years from now, where would you be?
So the theoretical limits are delivered efficacies are similar to LED.
Oh, wow.
So,
okay, so you've got a long road ahead.
So 220 lumens per watt is that theoretical limit. We think 140, 150 lumens per watt is certainly possible. We have made 3 advances over the last 2.5 years from 45 lumens per watt to 63 lumens per watt to 85 lumens per watt. But my favorite thing about the technology is the fact that it's a broad spectrum light source. Really beautiful light, much like sunlight, no harmful blue wavelength of any kind in an OLED.
See, when I was in your booth, which was totally, there was a feeling. I will tell you, the light felt very comfortable to me. And I assume it was the color temperature, but it just felt very, very comfortable.
I think it's a combination of the color temperature and the fact that it's broad spectrum. So it's much more akin to a light that you'd see sunlight look like.
You mentioned plastic. So, you know, and I know about this bendable, I assume that would be plastic, but you're telling me it's a very thin glass. So you can bend glass?
Yeah, so this is an innovation by Corning. We signed a joint development agreement with Corning in late 2014 to deposit OLED materials on their Willow glass. Willow glass is 100 microns thick, about as thick as a piece of paper, and we process that glass as you would plastic, and that glass can bend to about, we spec it about 100 millimeters, but it has a much narrower bend radius than that theoretically.
Why would you use plastic? The cost advantages?
Well, so plastic with barrier coatings is expensive. Actually,
Okay.
thin glass is probably cheaper than a really good barrier coated plastic. Okay. OLEDs don't like water, so or moisture of any kind. And glass is the best barrier to moisture that you can make an OLED on. So plastic, water permeates plastic unless it's got great barriers, and as a result, those cause either shorts or dark spots. So our Willow glass-based bendable product is highly reliable, very robust.
So really no reason to use plastic?
Well, plastic is cool. So there are applications where we think plastic is utility, and that might be wearables, disposables, advertising, packaging. These other applications would be really cool.
All right, so right now, where are the applications for OLEDs today?
So our OLEDs are used in general in architectural lighting. So mostly I would say architectural lighting. So the products that you saw, for example, at the Light and Building booth, most of those were more architectural fixtures, but Acuity Brands introduced a product called the Olescence, which is OLED downlight, LED uplight.
Is that through the Winona brand?
Yeah, that's through Winona, and it's a hybrid product that they've introduced that's very highly efficient, but also very cost-effective because they've combined the two technologies.
Tell us a little about industry behavior with regards to OLEDs.
So I think, there was a lot of hype, right, about OLEDs, and we only started our company in 2010. So the hype from 2002, 3, 4, 5, a lot of disappointment, I'd say. But we've combined the former Kodak team and the former Philips team and all of those related innovations and all the equipment and facilities that Philips built. And we're really very fortunate to have those facilities, but mostly fortunate to have the people. The people are incredible. And they've brought the technology with a smaller group, but great resources to really a market-ready product at this 85 lumens per watt, and also fairly cost-effective. And as our scale goes up, our costs will very naturally go down.
Drivers, can I use an LED driver with OLED, or do we need special drivers?
So we do have OLED-tuned drivers that are highly efficient with our products. So we have a couple that we've made ourselves because there weren't any available, and we've partnered with several companies also who have developed OLED-specific drivers. But there's also LED drivers that work just fine with our OLED light engines. They may be a little less efficient, but they're fairly inexpensive. So we've tested a number of drivers, standard LED drivers with our products as well.
And you only sell to luminaire manufacturers, is that right?
Yes, that's correct.
You don't have a line of products that
No.
you're selling out the back door.
So we're a small company, and we're partnering to get OLED products in our customers' portfolios so that they can bring cost-effective products to market. No, we're not making luminaires.
And they must love the fact that they can use some of the drivers that they may already stock for other products.
Yep, I mean, we work with them on
Building
their own.
materials.
Yeah, we work with them on their own drivers or try to find drivers that would suit the application space.
What about controls? How do we control?
So this is a solid-state device, right?
Okay.
So it's dimmable down to less than 1%. It's easy to control. When you use the right controls, it's very, very agnostic when it comes to the controls. We have a gateway site that we did with the Department of Energy in Rochester, New York, that's really cool. And the controls are standard controls that are integrated with the OLED fixtures.
You mentioned about the hype with OLED, and one thing we still hear a lot is that OLED is still very expensive. Now, how does it compare with similar products?
Okay, so the light engine for an OLED is going to be more expensive than an LED chip.
Okay.
But there's no diffusing, there's no heat sinking, there's no waveguiding to make a very uniform device. And when you take that and you build a frame around that or something that builds a fixture into that, there's less work to do. So the fixture cost actually can be very, very competitive with an LED product. Yeah, I think it's going to be a little bit more, but the premium is not 4 times that of a LED fixture.
Which it was, not too distant.
So I think you'll see things coming out that are, fairly cost competitive. So I know you will. So we're aware of them. It's going to be fun.
Okay, so you did mention bendable, and I think it's called Bend OLED.
Yep.
Tell us where you use this product. That has the willow glass. Where will you use that product?
So that actually has really excited our clients and our customers, just because it's so thin and so unique that you can get a nice distribution of light with a curve in it without doing really any optics. So if you have an application where you want to show the thinness of the panel in architectural space. The other application space that we have a lot of pull is transportation. So well, it's very lightweight. It's very lightweight and it's very uniform and it can curve around shapes. So in an automobile, it's easy to bend a light around the curve of a car or the interior of a car. Using that thin glass, and transportation needs light. They want lightweight, low heat, all of these great things that a thin OLED can bring to that market space is very, very exciting for them.
So again, your go-to-market strategy is through the luminaire manufacturers, but do you also have a team working with the lighting design community to get the product specified?
So we do. I think, again, awareness of OLED in its current state is important for us to help drive. And through the specifiers, that's really our team is working very hard. Our small team is working very hard to make sure that awareness is built for our Bright 3 product, which is our newest release product.
Okay, so your team is actually making sales calls with, to lighting designers, or do you have reps in certain markets that help make those sales
So we
calls?
don't currently have reps. We have mostly our team that's working with, through trying to explain this technology to the world. And this has been a challenge. I think the luminaire manufacturers, our customers really, are working with their reps to get that message out in the marketplace. And we're working directly with mostly the luminaire
And
manufacturers to do
again, these
that.
are non-commodity products, so the luminaire manufacturers love to get that specified
Right.
because they're going to make higher margins.
Oh, you sound like me.
Well, thank you. That's a compliment. But with education, tell us a little bit about this OLED forum and how that is working.
So in the U.S., there's the OLED Coalition. And the OLED Coalition is a group of OLED interested parties. And we've been working closely with the Department of Energy. It's not a Department of Energy coalition. It's an independent coalition. But we've worked very closely with the Department of Energy, who continues to be very interested in OLED in use for general lighting. That's been around for about 5 years now, and a lot of U.S. and international companies join that. In Germany, the OLED Leaked Forum was just founded in Germany, and very much like the OLED Coalition is bringing together interested parties for OLED to build awareness, because we're small, but some of these companies are very large. Includes Corning and Universal Display Corp and Merck and a bunch of interested OLED suppliers and manufacturers.
I'm not aware of Merck.
So Merck is not the pharmaceutical Merck, it's the chemical Merck that makes liquid crystal display materials and other specialty chemicals, and they make OLED chemicals.
Okay, how important is Europe to you right now?
So our primary targeted markets are Europe and the U.S. Of course, we're paying attention to Asia because Asia is such a big market, but our facilities are in Rochester, New York. We have manufacturing in Rochester and in Aachen, Germany, which is where the Philips facilities we acquired were located. And then from there, we stretch out across North America, I'd say, and then Europe. Very important to the market.
North America bigger than Europe right now?
I think so, yeah. I mean, for us, we've had a little bit more traction, but Europe is a very design-oriented place, and OLED is really a design-centric technology.
Right. Okay, well, Dave, this is fascinating, and thank you, and I will stop by your booth and learn a little bit more than I did in Germany.
Well, thanks very much, Randy. Nice talking to you.
Thank you.
Yep.